Great, okay, so today's lesson is all about trace tables, which is where we step through an algorithm and we write down exactly how the values in each variable changes. So it's something we just need a little bit of practice on. So if we have an algorithm, a trace table first of all recognises all of the variables or all of the expressions in our code. An expression is just a combination of values and variables and function calls and things like that. So first job, which is often done for you in an exam question, is to put all of the variables in our algorithm. For example, we've got num1, we've got num2, we've got count as a variable, and we've got the program output. It's not a variable, but it's something that we can calculate and work out from line 8. Then, every time we step through, we put in a value. So after we've run line 1, num1 has been assigned the value 0. It's been set to 0. Num2 on line 2 has also been set to 0, so we put that next to it in here. When we get to line 4, num1 has changed, so we can't cross it out and put 5. We move on to the next line and we just put the new value underneath. That's what a trace table means. You can trace the changes, you can see how the variables change. Next, we have a for loop. Is it going to carry on? Yeah, here we go. So for count in range 3, that's going to use count to go from 0, 1, 2, and it will stop just one before this number here. So count starts as 0. Doesn't need to be on a new line because it hasn't changed anything there already. So I've just done line 5. When we get to line 6, we're going to do a calculation. So num2 is going to be num1 times count. So num1, our trace table tells us, is 5. Count is 0. Anything times 0 is 0, so num2 is going to be 0. Now, this value hasn't changed, but we put it on a new line because we've put something to the right of it. So I'm going to move on to a new line and put it down here. Alright, so let's see, we go back round to the loop, and count is now going to increase. It was 0, it's now going to be 1, so I can put that in here hopefully. They put it on a new line, I probably would have put it on the same one. And then we calculate num2 again, which is this time going to be 5. Why? Because num1 is still 5. Count this time is 1. 1 times 5 is 5. That's why we put a 5 in here. So that's it basically. We just keep looping round until we've recorded the value of every change in here until the output is displayed after the for loop. So what's the point of it? Well, you use these trace tables to work out if there are any errors, to keep track of exactly what's going to happen. So your first job is to start here. I'm not going to do all of it for you, but we can start together if you like. Count is a variable, and we set it to 4 from line 1. Number is a variable that we set to 0 from line 2. Sometimes, and you don't have to do this, but often you will see, I want to put that on the other side, let's put it in here, insert to the right. You'll see columns that have expressions in. So I'm going to have count is not equal to 0. So it doesn't have to be just a variable, it can be an expression, a combination of variables and values and function calls. Is count equal to 0? No. So is count not equal to 0? Yes. So that means I'm going to repeat. Number is equal to count raised to the power 2. 4 squared is 16. Print the number. We're going to display 16. I've got up to line 6 the first time through the while loop. You'll need to carry on from there. So for activity 2, let's read through the question. We've got an algorithm written in Python. It's supposed to validate, that means check and see if it's sensible, separate parts of a code. It looks like there's 2 separate parts of the code. Code 1 and code 2. The user enters the first part, which is 2 characters, and then the second part, which is 4 digits. And then you work out a score that tells you whether or not it's valid or not. So we're not going to look at the code just yet. Exam technique, I always read the writing above and below the code before I start looking at the algorithm. This is what we want it to do. So this is code 1 and this is code 2. Case 1, 2, 3, 4 and what you want the program to do, that's quite important. I'm just going to zoom out so that we can see both sides of the screen at once. That's not particularly helpful. I'll show you a trick in Word which might be better. If we go View and Split, then we'll be able to see this table as well as this stuff at the same time. That's View and Split. So we've got some trace tables here. Let's scroll up on the top part and we'll trace it through. So score is going to be 0, line 1. Code 1 is going to be empty string. Code 2 is going to be an empty string. Code 1 is going to be, okay, so here we need to know what code 1 is. The user's typed it in, and from our test table, it's going to be WB on a new line because we're changing something. Code 2 is going to be the integer version of the digits 1, 2, 3, 4. Nice. Right. Then we're saying if code 1, 0, that's the first character of code 1, a W, is greater than an A, so that means it's further along in the alphabet, and it is, because a W is further on than A, and the first character of code 1 is less than or equal to Z, which it is, so this Boolean expression is true, this Boolean expression is true, both of them ANDed together is true, so therefore the score increases by 1. Awesome. Next if statement. If the first digit is further along in the alphabet than A, true. Oh, hang on. This is the second digit now, B. So A is further along in the alphabet. No, sorry. B is further along in the alphabet than A. There we go. True. The second character of code 1, B, is less than Z. It is. That's true. True and true is true. So therefore the score increases. 2. Is code 2 greater than 1111? Yes, it is. Score goes up. Is code 2 less than 9999? Yes, it is. Score goes up. If the score is not equal to 4, well, the score is equal to 4, so therefore this doesn't run. This does instead. Valid input score. Valid input 4. Is that what we wanted to happen? Yes, it is. Great, it works. So your job is to do exactly the same kind of thing, but fill in the trace table for case 1, case 2, case 3, case 4 on here. Okay. So the last part here, activity 3, we've got a slightly longer test table. Notice it's an expression rather than a variable. So if we start here, num table is this list of values. Index is set to 0 on line 2. Length is set to 0 on line 3. Total is set to 0 on line 4. Length then is set to the len of num table minus 1. Well, num table contains 1, 2, 3, 4, 5. 5 minus 1 is 4. So the length is 4 from line 6. Then we've got, is index less than length? Well, index is 0, length is 4, so index is less than length, that is true. Total is going to be total plus, so 0 plus num table, square brackets, index. Well, what's num table? It's this. What's index? 0. What's the first value in num table? 9. And then index equals index plus 1. I'm going to increase that down here to be 1. You get the idea. When you've finished, your extension is to find out examples of algorithmic bias, and it needs to be submitted, please, at the end of the lesson. I'll remind you when we get closer, to half term 8, Algorithms and Programming